Hi, welcome back. In this lesson, I'm going to cover with you many-to-many relationships. And I want to start by talking about the logical model. And we're going to be using, in this example, the training database. And I picked that one and put this in purposely because everyone that's taken this class has been a student and has attended classes before, so understanding the business context will be something that everybody can get their head wrapped around. So if we look at the logical model, we have two entities. We have a class's entity and we have a student's entity. And we can understand the relationship between the two is reciprocal. In other words, a class consists of many different students. So I may want to publish a class roster as part of a university. Here are all the classes, and here are the students that will be attending these classes, and if there's assigned seats or whatever, this is their seat in the class. On the other side of the relationship is that students can attend many different classes. So in a semester schedule, a student may attend 5 or 6 classes. Through the course of a program, they're going to attend multiple classes. So a student can attend many classes, and a class consists of many students. So we have an inherent relationship, reciprocal relationship, between the two entities that's many to many. Well, how do we establish that relationship? Well, we establish that relationship by using what's called an associative table. And so if we look down at the physical model, you'll see that there's a class registration table. And in the class registration table, the primary key we have consists of the class number and the seat number. And we join out on a one-to-many relationship between the classes table and the class registration table. Conversely, our relationship between the students table and the class registration table is a potential one-to-many relationship going this way, but because we have this associative table, it allows us to establish a relationship between the entities, students, and classes through this intermediate table. Now there's many ways where we can design and do things like that that are variant from this, but that's not really in scope for what I'm teaching here. What I want you to understand is that by using what's called an associative table, we can establish a relationship between two entities. And if you were to actually go and look at the classes and the students table, you would not find a direct link between the two tables. We establish that relationship through the associative table. And so how do you know that a join is many to many? Well, this kind of gets into a little bit more of a nuanced type of thing. You would know because the entity relationship diagram tells you, or when you can sometimes find, like in this case through business context, that there's certainly a relationship between the two entities, yet when you go look at the physical model, you don't see an inherent relationship. So you know what's up with that. So not quite as clean of deducing is the relationship many to many as it is deducing is a relationship one-to-one or one-to-many, where we can do by examination of the primary and the foreign key relationship. All right, so let's head on over to the workbench, and you should already have the following 5 files open that was called out in your workbook. And so let's just kind of take a look at the data to nail this topic down. And in the first one, I have join MM1A. It's just a query bringing back the table, and you can see the table is nothing more than these 3 columns. So essentially what we have are 2 foreign keys and then our seat number for each of our classes. If we take a walk on over to join MM1B, what we've done is we've resolved the student side and returning back the student's first name and last name by joining student to the class registration database on student ID equals student ID FK. And so we've returned that. Kind of an interesting note as we look at this, we've got this null placeholder. Well, what's that all about? Well, let's have a quick look at the students database. So we'll just do a quick examination of that. And if we look at that, we find that row 1 is actually reserved as a placeholder. So the idea is this data structure would be used as a system to schedule people for classes. And so we need a marker to denote is a seat open or available when we're setting up a class. And so we do that by setting this placeholder marker in the data. So kind of an important thing, sometimes data can be very relevant, the data itself, to how the tables are being used in their particular business context. Alright. If we go now have a look at MMC and we go, well, how would we do the second table join? Well, we do it exactly the same as you've been joining multiple tables. There's no differentiation or difference just because we're dealing with an associative table. In this case, what I've done is I've joined the classes table onto course registration on the key classes_num equal classes_num. And we're returning back the course designator foreign key, which just happens to be what would be considered a natural key, which is the course designator or the short course name. Now, let's say I wanted to get the course name. If I look at the classes table, I won't find a class name in this particular table. I'm just going to find the course designator foreign key, this natural key, which is a short course name, essentially. So it'd be like Psych 101, and then you have a long name for a course or something like that. So what a natural key is it's a key where the data has some sort of meaning to the person looking at it. You know, whereas this right here, or since we're talking about keys, let's go back to the previous one. This class num by itself, it doesn't really have any meaning. What is class num 5? Well, I don't know. I guess if I'm someone that works with the database and I'm familiar with all the classes, I might know the answer to that, but I don't know, so it's just a key. Whereas over here, this is actually part of a key, but it's what's called a natural key, so the data itself has some meaning to someone that's viewing it. Alright, so let's head back to the PowerPoint real quick. So if I wanted to resolve that key, I can join the classes table to the courses table on these columns. So let's go back to the designer and look at 1D. And you can see I've joined now courses to the classes table. So I've joined courses to the classes table where course designator is equal to course designator FK, and that allows me to get the course name. And then finally, maybe I wanted to display this in a way where I don't want to see if the value is placeholder or null. I just don't want to see anything. So what we can do is we can write a case statement, which you've already been introduced to, and we can concatenate the student name, and if the student name is equal to placeholder, well, we're just going to return back an empty string. That's all I've got for this particular subject I don't have an exercise on this per se, but as a quick recap, in terms of joining to an associative table, the mechanics are the same as if you were going to join multiple tables together. Same exact mechanics. And again, how you would know that something is an associative table is you would understand that through the ER, typically through the ER model, ER diagram that you've been given. So that concludes this lesson, and I'll see you later. Take care. Bye.